everyone, and welcome to today's Explainer. We're diving into a really fascinating snapshot of the AI landscape as of late July 2026. Now, if you've been just skimming the headlines, you might think AI is, just some magic code floating around in the cloud. But today we're looking at the absolute staggering physical realities, the massive measurements, and the very real human friction that's defining the industry right now. We're talking gigawatts of power, terabytes of raw downloads, and multi-billion-dollar pipelines. Let's get right into it. So, here's our agenda for today. First, AI's massive new scale. Second, big tech under pressure. And third, we'll see how healthcare AI is gaining serious traction. Starting off with Section 1, AI's massive new scale, and the sheer physical reality behind these trillion-parameter models. 10 gigawatts. Just to put the raw power that AI now demands into perspective, SB Energy, which is backed by SoftBank, is actually proposing a new data center in Piketon, Ohio. And this isn't just on some random empty plot of land, it's literally situated on a former uranium enrichment site. A 10-gigawatt facility is on a scale that rivals the power consumption of entire small countries. And it's all going to be entirely dedicated to feeding the next generation of compute. Over $500 billion. Yeah, you heard that right. That is the projected build cost for this single Ohio campus. When you're talking about $500 billion for one facility, your traditional venture capital model basically just breaks down. This massive capital requirement, explains by OpenAI, is reportedly seeking an unprecedented $250 billion financial backstop from Nvidia just to handle leases and construction debt. Let's break down the actual mechanics of this proposed deal because it's fascinating. Essentially, Nvidia would guarantee the financing tied to the lease and construction debt for OpenAI at that 10-gigawatt Ohio facility. But on top of that, there's separately discussed financing of up to $350 billion more, specifically for chip purchases. Now, to be completely impartial here, it's really important to note that while this framework comes from highly credible reporting from the Wall Street Journal, it remains completely unconfirmed by Reuters. So it's a reported deal, not a signed one, but man, it shows us the sheer infrastructural shift happening behind the scenes. And if you want a detailed look at the instructions and measurements for the application of this new technology, look no further than Moonshot AI's Kimi K3. This is a 2.8 trillion parameter model that just became the largest open-weight release in history under a modified MIT license. For practical application, if you want full precision using MXFP for quantization, which is a data format that really speeds up processing, you're managing a massive 1.4 terabytes of data. Even when it's compressed, you're still looking at a 594 gigabyte download size. Deploying something this large requires serious, localized hardware just to get the thing running. But here's the catch. Despite that massive physical scale, independent testers are actually flagging a 51% hallucination rate. So for developers, the instruction here is crystal clear. You absolutely cannot just plug and play. Real-world application of these models requires incredibly rigorous guardrails and extreme testing before you can even think about trusting them in live production environments. Moving on to Section 2, big tech under pressure. We're looking at regulation and internal friction. Over on the regulatory front, the EU Commission has just ordered Google to open up its Android ecosystem to rivals like Claude and ChatGPT under the Digital Markets Act. And this isn't some vague policy request. It's a highly specific set of procedural instructions. Google must grant these rival assistants voice activation, access to screen context, OS-level app actions, and even a share of the on-device computing resources. Essentially, the EU is mandating that third-party AI gets the exact same operating system-level permissions that are currently exclusive to Google's own Gemini. So when does this actually happen? Well, the timeline requires Google to start sharing search query data by January 2027, with the full mandate supposedly taking effect in July 2027. Actually, scratch that. As an observer, you should really treat July 2027 as super optimistic. Google is already warning of unprecedented privacy and security risks, and they'll almost certainly appeal the ruling. Because of that, the realistic window for this to actually impact your devices is probably more like 2028 or 2029. But friction isn't just coming from regulators. It's also entirely internal. According to a recent Bloomberg report, XAI is drastically lagging in computing efficiency. If you look at FLOPS utilization, which basically measures how effectively a model uses its raw computing power, the industry standard usually ranges from 35% to 45%. XAI, on the other hand, is currently sitting way down at roughly 11%. And this efficiency problem is directly tied to human friction. Right now, amidst immense financial pressure ahead of a potential SpaceX IPO, xAI is going through a massive reorganization. Starlink veteran Michael Nichols has taken over engineering to aggressively push their model, Grok, toward what they call Claude parity. But the reports indicate he's trying to do this with a shrunken pre-training team and amidst several senior departures. It's pretty much a perfect storm of sky-high expectations hitting internal bottlenecks. Let's look at Section 3. Healthcare AI gains traction, and how this tech sees real-world application. $1.5 billion. That is the massive price tag on Tempus AI's recent acquisition of Personalis. What's absolutely vital to understand here is that in the healthcare AI space, financial scale is actively shifting. It's no longer just a race to see who has the smartest code, it's becoming all about who actually owns the physical data. The key takeaway for us here is this incredible merging of physical biological infrastructure with AI processing. By consolidating clinical genomics and liquid biopsy data pipelines, which is essentially analyzing physical blood samples for specific cancer markers, Tempus AI is revealing a pretty harsh truth about the industry. Owning the physical lab and distribution network matters just as much as your algorithm. Think about it. If you can't feed your AI continuous, real-world, physical patient data, then having the smartest model in the world really isn't going to help you at all. Now for a totally different measurement of real-world application, consider this number. 70,000. NHS England is actively rolling out Ambient AI voice tech to 70,000 clinicians. The practical application of this works immediately in the field. Instead of a doctor spending hours typing up notes, the Ambient AI simply listens to the consultation, structures the medical data, and securely files it. We are talking about tens of thousands of highly trained humans getting hours of their day back, right now. So as we step back and look at the whole picture today, we've seen that AI requires massive gigawatt-level physical infrastructure and literally billions in backing. Yet simultaneously, it's running face-first into incredibly strict digital regulatory walls and internal corporate friction. The gap between open-weight code and actual physical deployment is widening rapidly. Which leaves us with the billion-dollar question: who will truly control the future of these networks? Will it be the software developers, the government regulators, or the companies that own the power grid and the data labs? Time will tell. Make sure to subscribe to AI Vanguard AI to stay at the cutting edge of industrial AI as we find out. If you found this synthesis valuable, please like, comment, and share. Keep exploring, and I'll see you in the next explainer.